Hello and welcome to another creative coding video. Today we're going to continue looking at recursion, which we started last time. We saw that recursion is a really powerful idea that allows us to describe and create really sophisticated designs with lots of detail in a very concise way. We saw that we had to think quite a bit about our designs, our patterns, in order that we could extract out the thing that we could turn into a recursive description. And then the code was quite small. Now, I did say that for many people, including myself, recursion's quite a hard topic to get into. Once you understand it, it's not difficult at all. It just needs a little bit of time and experimenting to get into. So today we're going to be looking at just an example using recursion. So we're not going to learn anything particularly new, but we're going to experiment, and I'm going to be thinking aloud, as it were, just to kind of share with you how we might go about thinking about a design and encoding it in a recursive way and seeing the results. So on the screen you can see what I did kind of give you a sneak peek of last time, which is a plant, a tree. There's obviously lots of interesting detail there. The tree seems to be fairly organic. If I run the code again, I should get a slightly different tree. That still seems to have, oh, I like that. Still seems to have an interesting, fairly organic structure. And if you look closely, you'll see lots and lots of tiny lines. We're not going to write code to draw every single line. We're going to see if we can think about describing a tree in a recursive way, so that we can write some small, well thought out code that creates images like this. So let's have a look at this picture just to kind of pick out a few features. So you can see that there's a branch at the bottom, or a tree trunk, which splits, and then that splits, and then those split, and so on. It might look like we've drawn leaves, but there aren't. These are just very thin branches. They're coloured green, so it gives the impression of foliage, I guess. Let's run it again. There you go, this one's a bit thinner, more bunched up. There's another one. I quite like them when they're spread out. That's a nice one. So let's have a think about how we might do that. So when we were talking about recursion last time, a key observation was spotting how a pattern is self-similar. So there is the whole pattern and then smaller versions of that pattern in or around the main one. We saw that with circular designs and square-like designs. If you need a reminder, it is worth going back to have a look at that, because I won't go over all that material now. So if we think back to what we were working on last time, we had a sort of a circular pattern with smaller circles on each side, and each of those had smaller circles on each side. And what we recognized was that, let me change colour here. What we recognized was that the whole pattern was repeated at smaller scales. So we had the pattern was a big circle, and then a smaller version of that pattern to the left and to the right. So we said a pattern was a big circle, and then a smaller pattern to the left and a smaller pattern to the right. So therefore each of these could be described in the same way. So that pattern to the right, this one, is a circle with smaller patterns to the left and right, and so on and so on. So that was what we looked at last time, can we apply that thinking to a tree? Let's have a think. So we might say that a tree is we might say that it's a branch with smaller trees coming off the end of that branch, and each of those has a smaller tree. Let me choose a different colour to illustrate what I'm trying to say. So at one level, this is our whole pattern, that one there. We can call it P or tree or T. Now, instead of describing every single branch in that, we can say that tree is a line, which is a branch or a trunk. It's this one here, plus a smaller tree going to the left and a smaller tree going to the right. So T left and T right. That's very similar to what we had before. We had pattern to the left, pattern to the right. Let's draw a picture here. Now these are going to be slightly at an angle now. That's one. And here's one here. Can you see? So it's the big tree is a trunk or a branch with two trees emerging from it. And then if I choose a different colour just to help us see more clearly, then this tree, let's focus on this one here, this tree is a branch with a smaller tree coming off to the left and right at an angle. And then if I zoomed in on that one and chose a different colour, I don't know, maybe that, you'll see that each of those is a branch with a smaller tree coming off, and so on and so on. Picture's looking quite busy already, but the idea is the same. Now let's write that down in plain English first before we code. It's helpful when we write things down in plain English because it helps us clarify what could otherwise be quite a complicated idea. So let's do that. So as usual, I'm logged into openprocessing.org and I've made sure that my Simple.js library is enabled, and I've turned on Simple in the setup section, and I've got an empty draw function ready to go. So what we did last time, we said my pattern, I think, didn't we? Let's call ours my tree, or just tree will do. That was the starting sort of function. Then we had to define it. So let's start writing. I haven't filled in all the details here, I'm just kind of typing and thinking aloud. So I've got a function tree, and it's going to be a branch and then a smaller tree to the left and a smaller tree to the right. That's typing in plain English to help us kind of plan out how we're going to code. It helps us think more clearly about it as well. Now, do you remember how we defined the pattern in terms of itself but smaller? So we'll eventually have to be calling tree with some parameters at some point. And the same here, tree, some parameters at some point. Don't know what those parameters are yet. Now, we have to stop at some point. Do you remember how these functions could call themselves again and again and again and again? We don't want that to go on forever. We talked about that last time. And the way we dealt with that last time was we said we stop when the size of the circles or squares got small to a certain point, and then we'd stop. So let's go back to our tree here and say, well, when do we want to stop? And we could say we stop when the branch line has got shorter and shorter, because it starts off quite big. Can you see there? This one here. And then the next one is that sort of size. And the next one is that sort of size. The next one is that sort of size. We're drawing them smaller and smaller. So we might start off as size, I don't know, 200 maybe. And we might end up with size, I don't know, 50 or 20. So let's start with, say, I don't know, size 50 just to get going. I will say once we've reached size 50 for the branch, then we stop. So in the previous example we had circles and they started at size 200 or 400, I can't quite remember, and they got smaller and smaller, and then we said stop when they are size 10 or 20 or 5. This time we've got lines for the branches, and we might start at size 200 and we get smaller and smaller and we stop at, say, 50 as an example. So let's write that in code. We'll say only continue. Let's write a comment to do that. Only continue if branch size isn't too small. So if, what could we call our, let's call it a length. If the length is more than, I don't know, let's just say 10. We said 50, didn't we? I said 20. So only draw smaller trees if the length is more than 20. Okay, so we need to have a length parameter. So the tree has to be passed a length. So we might start our tree off with length, I don't know, let's say, do we say 200? Yeah, okay. So we start a tree off with length 200 as the first branch. That's up here. So, and that calls a function tree with the 200 as a length. If we draw a branch, or we should draw a line, shouldn't we, from somewhere to somewhere. Let's call it x1, y1 to x2, y2. We'll fill in the details. We're just putting that in so we know we're going to draw a line. So we've drawn a line as a branch, and then at the end of that line we draw a smaller tree to the left and smaller tree to the right, but only if the length is more than 20. Can you see how the code is starting to develop? Structurally it's the same as the patterns that we did last time with the circles and squares. So in some essence the underlying structure is the same, and the recursion is of the same kind. And you'll be able to spot this in more advanced code or other people's work, or when your own work gets more and more sophisticated, you'll start seeing similarities. Okay, so now we need to fill in some details, don't we? So at the moment we don't know. No, actually I'm rushing ahead. When we call the new tree, we need to make it smaller. That means the length that we're passing it has to be smaller. That's similar to what we were doing before with the circles. So let's see. It has to be called with, we could half it, or we could say, I don't know, let's go for length times, I don't know, 0.5, so we half it, So each branch is it gets half at each level of the tree. So the first branch, which is the tree trunk, is 200, then 100, then 50. Length times 0.5. Let's put some spaces in just so we can read the code easier. Great, okay. Now what's missing? These things, the positions, x1, y1, we haven't explained what they are, but it was useful to write it down like this so we know that we need to draw a line. So the starting point, so let's look at our drawing. The very first thing it has to draw is a line from here up to here. So that's the starting point is here, and that's the end point, and the length is going to be 200 to start with. So this one, we'll have to pass the starting point to the function, otherwise it won't know where to start. Okay, let's do that. So let's say the first one, we write it halfway across the canvas and not halfway down, a bit further down. Let's say 500. So that's kind of in the center but down. So that's the starting coordinate. So we put that in, x, comma, y. So we draw a line from x, y to somewhere. But what is x2, y2? Let's have a look. Let's think about that with a drawing. Okay, so we've got x and y, and we want to know what this point is, the end of the line. So the start is xy, the end has to be, let's call it for now x2, y2. Right, and we know that the line is 200 units in length. How do we work out what x2 and y2 is? Do we just say it's upwards, so it's the same x, but y2 is just y minus 200? That could work, but it wouldn't work for any of the other branches because they go off at an angle. So we need to think a little bit more generally about direction. Now we've done angles and calculating with trigonometry in a previous video, so do go back and have a look at that. So we'll say that here's our starting point, x, y, and we want to draw a line up there, and it's got a length, let's call it L, and it's got a direction, and we need to measure a direction in terms of an angle. So let's call that an angle, let's call it A, an angle. Now we need to work out what x2, y2 is. Can we do that? We can. We can do that because we can use trigonometry to work out these distances that I've just coloured in green. Now you'll remember, you should remember, hopefully, you can go back and have a look, that this thing here, let's call that, let's just draw a 9. And that one is going to be L times sine of the angle. This refers back to those videos that we did where we talked about converting angles to xy coordinates. And that's what we're doing here. You'll see why in a second. This one here is L times cos or cosine of the angle. And you might think, what, A, how is that? That's got nothing to do with what we did before. It does, because before we had angles starting just from this direction, angle, and we said that if that was x and that was y, we said that x equals that radius. Let's draw the radius there. Radius times the cosine of A, and we said that y equals the radius times the sine of A. So we've done that before, and all we've done now is taken that picture and rotated it a bit so that our angle starts from the top and moves anti-clockwise, whereas normally we start from this direction and count that way with the angle. Here we're starting at the top and going this way. So we've just turned that around, and you can see that the equivalent top line here is this one here, this y, which then here is x, hasn't it? So that's r times sine A, and that's why we've said that's the length times sine angle. So if we know x here, and we want to work out what x2 is, which is here, we say x2 equals x minus that distance, which is L dot sine A. Does that sound complicated? Hopefully this visual approach has shown you why we're doing that. We're saying this x2 is x minus a distance, and that distance is this green one at the top, which is this one here. And the same with y2 is the old y, the start of the line, and because in this computing environment y goes downwards, we need to say y minus that distance, which is L, the length of the branch, times cos A. So that's the magic equations, these, that we need to work out the end of the line. Let's do that. So we know what x is, we just need to work out what x2 and y2 are. So we can work that out. We can say var x2 equals x minus length times sine. Was it sine? Yes, it was. Sine of the angle. And we say var y2 equals y minus length times cos of the angle. So that now gives me the end of the line, the other end of the branch, from the start of the branch. Start of the branch xy, the other end of the branch x2, y2. What's the angle? We haven't got one, have we? So let's say we start at an angle and we say it's 0, so it's straight up. Let's call that angle. So that means 0 is the angle. That's the first time tree is called, the angle is 0. So the side of an angle will be 0, and it should work. We'll try it. So we've got that bit right. We've drawn the line now. There. Now we're saying if the length is more than 20, call tree to the left and right. Smaller because it was half the size. Let's fill in those other little parameters now, which we've kind of talked about. We've said it's x, y and angle, but they're not the same, are they? Because now we're saying we've got to the end of the line. The new tree starts at the end of that branch. Let's draw a picture of that just to kind of illustrate what we mean. Let me clear the screen a little bit. Okay, so we said let's focus on this one here, this branch for example. So we're starting at x, y, and we know it's at an angle, and we've just worked out what x2, y2, we just worked that out using trigonometry. So we've drawn a branch, a line that goes from here to here. There you go. And now we need to do two more smaller trees to the left and to the right. Where do those new trees start? Well, the new trees start at the end of that branch. There they are, two new trees. And they start at x2, y2, they don't start at xy. So this one, this tree, started at xy here, but these two start at x2, y2. Let's do that. So they start at x2, y2. Can you see the first one starts at xy there, but the next ones start at x2, y2, and they go off at an angle. What's the angle going to be? Well, one's to the left, so let's increase the angle a little bit. Let's say 10 degrees, let's say 5 degrees. And the other one is to the right, so it's angle minus 5 degrees. It's minus because this is the convention of anti-clockwise is where the angle gets bigger. So if we're rotating it to the right, the angle is minus 5. Draw a picture. So tree, branch, new tree is going off in that direction and that direction. Now that angle, this one is at plus a little bit, and this one is at minus a little bit, the angle. So that angle might be plus 5, and this angle will be maybe minus 5. Do you see? So angle grows bigger that way and gets smaller that way. Now let's see, would this work if we ran it? I can't see why it wouldn't. Don't think we've missed anything out. We've got the right number of parameters, haven't we? 4 parameters, x, y, angle, length. X, y, angle, length. Coordinates, angle, length. Coordinates, angle, length. Let's try it. Moment of truth. Let's see if it works. Yeah. It kind of worked. Although it doesn't look quite like a tree, but the structure is there. You can see there's a first branch, the first trunk, and then that splits into 2 for smaller trees, and then they split into 2, and so on. Let's increase the angle to say 20 there, so it spreads out more. There you go. Starting to look more realistic. Yeah. So we've done that. This is it. This is now a recursive tree. Everything else that we're going to do now is just refining the style, perhaps to make it look green, perhaps to adjust the variation of colour and the thickness of the branches. But the essence, the recursion, that's done. We don't need to do any more now. That was the thinking that was required to make a recursive tree. Let me prove it to you. So let's say we want the branches to start off at, say, I don't know, let's say still size 100. If they're starting at 100, we should get more levels to the tree. 1, 2, 3, yeah, well, we didn't quite, did we? Let's make them get smaller by a smaller amount. So instead of halving them, let's make them kind of 80% of what they were before. So times 0.8 for the next branch. Let's try that. There, wow, look at that. That's suddenly really interesting. So the first line is size 100, then 80, because that's 80% of that, 0.8, and so on and so on. So the lines are getting smaller, but not halving. It's getting smaller at a smaller rate. So we get the opportunity to draw much more of the tree. And Yeah, I mean, that on its own looks quite nice. And look at the amount of lines of code we've got. Just that. I mean, there's not much, is there? And we've got something that's really quite detailed already. Let's change the color. Let's use HSB mode. It's easier to kind of get variations of the same color there. Color mode HSB, and let's say we're going to have stroke. Green was, I think it was 120, wasn't it, on that color wheel? Let's call it, I don't know, saturation of, I don't know, 90. Let's just try that. That's a bit too bright. Let's make it darker. Hue, saturation, brightness. Let's say 50. There, that's a nicer green. What's the next thing we might want to do? Do we want more detail? Maybe we should make the lines thinner. So let's say stroke, weight. The default is 2, let's say 1, so we can see more detail. Yeah, kind of. Maybe if we went further into the tree so that we stopped at 10, not 20. Let's see what that looks like. Wow. That's kind of chopped off at the top, but there's a lot more detail there. I mean, this is impressive as it is. You know, given our approach, which was to think of a tree as a line with 2 smaller trees, and then each of those is aligned with 2 smaller trees, and so on and so on. That's a recursive definition. So a code just reflected that, and it's quite concise, and we've got something as detailed as this. Let's make the branches, the lines, thickness that starts off thick and gets thinner towards the top of the tree, so that the first branch here, the first trunk, is thick or medium, and they get thinner and thinner and thinner. That'd be an interesting idea, wouldn't it? So we move stroke weight into our tree function. So we say stroke weight. It's not going to be 1 all the time. It'll have to depend on how far down the tree we are. And one way of doing that is, we could have another variable to keep count, like depth or level, but we can just use the length because that gets smaller anyway, doesn't it? The further up the tree we go. So we might say length. Let's see what happens there. I've got a feeling of a length of 100 might be a really thick line. Yeah, that didn't work so well. Let's divide that by, I don't know, 20. Will that give us a better... Yeah, that's not too bad. See, it's quite thick here, and gets thinner and thinner and thinner. It's starting to look more realistic there, isn't it? So thick, thinner, 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 thinner. So that's a nice thing we've done there. We've just said stroke weight is the length divided by 20, and the length itself gets smaller as we recurse further and deeper into the tree. Okay, let's change the colour as well. Let's vary it. So let's say instead of stroke being set once and for all, we say, I don't know, we say, let me add a little comment just to explain what we're doing. Current detail. So it's the thickness of the lines and the colour. So stroke is 120, which is the green, and then we might say saturation 90, hue, saturation, brightness. Maybe the brightness can be something that depends on the length. Hue, saturation, brightness. Let's see what effect that has. Length. So let's predict what that's going to do. It starts out at 100 and gets smaller and smaller, so the brightness will get smaller. What will that do? Okay, so it's very bright to start with, and then gets less and less bright, closer to black. Didn't want that, do we? If anything, it's the opposite. Or we could just have another parameter called brightness. We can fiddle around with more kind of expressions, or we could just say, do you know what? I'm going to start off with a brightness, let's say 50. So I'm adding that to my definition of the function 50. Or no, we call it brightness, and that's brightness, and then that one we'll vary it as we go down the tree. So we'll say brightness. Why don't we add a randomness to it? So a random parameter, a random number to it. So we'll say brightness plus or minus something. So it doesn't just get darker or lighter, it could go darker and lighter. So we'll say a random number between, I don't know, -10 and 10. So not too many swings. That's there. Copy and paste that there. Let's just talk about that again. We start our tree with a brightness of 50. That's there, brightness in the definition. We use it to set the lines, color, hue, saturation, brightness. And then when we draw the smaller trees, we pass the brightness along, but we adjust it by a random amount. So it could get slightly bigger, could get slightly smaller. So this might become 53, and this one might become 48, and so on as it does more and more levels. Let's see what effect that has. Oh, that's interesting. So yeah, there's lighter and darker. Oh, is that what I wanted? Let's run the code again. I made a mistake somewhere. Yes, I have. I put the angle in the wrong place. Yeah, it pays to get that right, doesn't it? Let's oops. So that was angle plus, what did we say it was? Plus 20. And then this angle was... Did you understand what I did wrong there? My function, my tree function is position xy, brightness, angle, length, and I got them the wrong way around. I said position, instead of brightness I had angle there, so I just needed to get them in the right order. So it's brightness, angle and length. Let's try that again. There, much better, much better. So that starts off with a green with brightness 50, and now you can see some of the branches as you follow them, the brightness does go up and down. Some are lighter, some are darker. That creates a more realistic kind of foliage effect. Yeah, that's quite nice. You can keep refining this, you know. But I think we've done a reasonable job there. What else could we do? I know. I think that these trees are, well, they're symmetric, aren't they? They're perfectly symmetric, and each of these branches is exactly splitting plus or minus 20 at each time. So plus or minus 20 there, plus or minus 20 there, and the examples we saw earlier weren't doing that. They were a little bit more random, and real trees aren't perfectly symmetric, and the splitting isn't done at exactly plus or minus the same angle. So let's introduce some randomness into that. So this is the angle at the moment, and one tree goes off at angle plus 20, one goes off at angle minus 20. Let's randomize that. So we'll say plus random number between two values. Now what would they be? We want this one to go to the left a bit, so it's 0 and something. So what this means is the angle will get bigger because the random number is between 0 and 30. So it could be angle plus 0 or angle plus 30 or angle plus 20, but it won't be angle minus 5, which means it will generally go around, it'll go towards the left. And the same idea here, but the numbers will be different. So random number minus 30 to 0. So this one will say yeah, we could have done it the other way around. So what I've done here is angle and a random number between minus 30 and 0, which means it moves towards the right. Now I had this as minus before, so let's actually keep that. Yeah, let's keep that, keep it consistent. So this now generates a random number between 0 and 30, and there's subtraction, which means it goes to the right. That's fine, let's keep it like that. Let's see what effect that has. There you go. The trees are much more random now, and the branching's more organic and different. There, see, isn't that interesting? So this one's got a big branch to the left, clump at the top, not much to the right. Run it again. Now if we vary that parameter, say 60 and 60, it should spread out a lot more. There? That does spread out, but it doesn't look quite like a tree. Maybe it does. I don't know. Yeah, that's interesting. That is interesting. It looks more like a lung. Or the veins in a kidney. Let's rein that back in again. Let's make it back to 30. Interestingly, if we said one was bigger, so 60 to the left and 30 to the right, it should kind of be biased in one direction. These are, aren't they? These are biased towards the left. Well, that's very biased towards the left. Yeah. That's interesting. I like that. Let's bring that back down to 30 again. I mean, you can try 40, 50, try your own kind of numbers, see what effect that has on how much the tree spreads out as it grows. What else do we want to do? What if we made the tops of the branches even more detailed and smaller? So instead of stopping at 10, let's say 5. What will that do? Well, it takes a bit longer to draw, and there is certainly a lot more detail now, but it's kind of saturated a little bit. Yeah, it's drawn over each other quite a lot. I mean, it looks nice. I like it. That definitely looks quite nice there in the middle. Looks very realistically like grass. Let's run it again. Yeah, that's interesting there as well. I like it. It really creates a nice texture, doesn't it? What do we do when we've got lots of detail and it's becoming saturated? We use translucency. We've done that lots of times before. So let's make the branches a little bit translucent. Further up the tree we go. So we've said stroke. We just need to add a fourth number, which is the translucency, the alpha value. Now what would we... It's between 0 and 1. What do we... Let's just try length divided by, I don't know, something 30, let's say. So when the length is big, the alpha value is high, so it's not so see-through. As length gets smaller, that translucency number gets smaller and it becomes more see-through, which is what we want. We want the detail at the top of the tree to be slightly more see-through. You can just experiment. You don't have to think through it like I have, although it's useful to. You can just discover these things by experimenting. Let's have a go. Yeah, that's interesting, isn't it? Yeah, so it's quite solid at the bottom, and as the further up we go, it becomes more and more see-through, so we start to see more of that detail. It looks finer and softer, doesn't it? That's quite nice. That is quite nice. Yeah. You can experiment with different colours. I mean, you can say the colour is, I don't don't know, let's say if it's a red tree, 0, hue 0. I don't think that'll look like a tree, but that's interesting, isn't it? And you can always mess around with the colours. You can always say that the colour also varies with length. Well, let's try that. Let's say it's plus length over, I don't know, 30 again, just to try it. That didn't make so much of a difference. Let's just add length instead of dividing it. Yeah, so it's got some interesting colours there. Of course, the length is bigger further down the tree, so the colour will change more towards the bottom. Yeah, so you can experiment with things like yourself. I'll just keep it like I had there. What else could we do? I think we could stop there. I mean, it looks very much like what we were showing earlier. It takes a while to draw sometimes because there's a lot of detail. I think I might shift it down a little bit because it's quite near the top and there's a bit of a gap at the bottom. So all I need to do is change the start position. I don't need to mess around in the function, just the start position. So maybe I'll just say 520, just nudge it down a bit. Let's see what that looks like. Yeah, that's nice enough, isn't it? And that's a nice tree, I like that. Yeah, I like that. So I'll stop there, and just to recap, what we've done is we've talked through how we can think about something that's a pattern, a design like a tree, and see if we can think of it in terms of a recursive definition. You know, can we say it's the design, the pattern, is something plus smaller versions of itself? And we managed to do that. We said a tree is just a branch with two smaller trees, and then smaller trees, and then smaller trees off those. The definition is recursive, and that means we've got the magic there, which allows us to write very simple, efficient code. And I showed you earlier, we just had a very simple black and white tree. All the other code we've written is just about styling it with thickness and green and different colours. So it's a very powerful technique, but I'm not going to pretend it's easy. And the difficulty is not the code or the programming language or the instructions. The difficulty is getting a piece of paper and a pen and trying to work out what that recursive definition is. You know, is a tree just a branch with two smaller trees like that? And we can change that definition. Do you remember we were kind of adding and taking away to that definition when we were looking at the video last time? What if we said we've got another branch coming off, so it's a third, so a tree is a line, a branch, with one tree coming off to the left, one to the right, and then maybe another one to the right at a much bigger angle. So this one was slightly to the left, slightly to the right. Let's say this one is much more to the right. Let's experiment there. I know I was going to finish, but I think this is an important thing to show. So let's first dial back the details so we don't get lost. Let's say 50, just so we can see what's going on. There you go. Now let's add, again, writing in plain English first, smaller tree to the right, but more to the right. So let's just copy and paste that code so it's easier to change. Copy, paste, and all that's changing is we're starting at the same place. We're adjusting the brightness by a random amount. We're saying that the length is going to be smaller by multiplying by 0.8. We're just saying that it's much more round to the right. So we might say, let's say 20 to 50. Let's draw a picture of what that means. So line, that's the end of the line, and then we've got angle which could be going to the left. So 0 to 30. So the first tree could be anywhere in this range, the first smaller tree. The next one is 30 degrees in the other direction, 0 to 30, so it could be anywhere in there, that way. And our third one, our third branch says 20 to 50, so it's going to be 20 is about there and 50 is here. So it could be coming off that way, somewhere in there, in that range. Let's try it. So we're subtracting that so it's to the right. Let's try it. Let's see what happens. There you go. You can see at each branch there's 3, at each point at the end of each line there's 3 branches coming off. So it's much more, well, it's certainly lopsided to the right because there's only 1 going to the left and 2 to the right. But it's a denser tree now, isn't it? Let's add a bit more detail. Let's say we go to 30. Yeah, you can see that. So that's an experiment you can do. Or the other thing you can do is to say, no, we're not doing that. We are instead making the length go vary more randomly. So we might say, instead of 0.8, we say random number between, say, instead of 0 to 100, let's say 50 to 100 divided by 100. So this will go from half to 1. They get small too quickly. Let's say 70. Yeah, that experiment didn't work quite so well. So we'll stick to reducing it by 0.8. You can probably refine it and make it work nicely, but I just wanted to show you some of the things you can do. There we go, final look. Lovely. So yeah, do have a go yourselves. Experiment, try different things, try different schemes for the colours. More importantly, try fiddling with the recursive definition yourselves. So I had 3 branches instead of 2. You might have other ideas. Actually, I'm going to try one more thing. I know I'm being a bit naughty, but there is just one more thing I want to do. And that is this. So instead of, we've got a line, instead of just 2 branches coming off the end of it, let's have one coming at the halfway point. So this is x, y, this is x2, y2. So this one will be halfway between the 2, and that's, you can work out the average there. You can say x plus x2 divided by 2, that's the half. So we can do that. So let's do that there. Let's have that going in one direction. We can say, I can say another small tree to the right, but branching at halfway along line. So it's, instead of x2, we're saying it's going to be x plus x2 divided by 2. That's the average, which means it's halfway along the line. And we'll say here y plus y2 divided by 2. If you're not sure or not convinced, let's add to this already busy diagram. Let's say here's a branch. This is x, y, x2, y2. What's the halfway point? Well, it's halfway between x and y2. Sorry, it's upwards. It's halfway between y and y2. So it's the average which is the average is calculated as y plus y2. So you sum them and then divide by 2. The same here, along here, it's the average of x2 and x. So it's x plus x2, so x plus x2, all of that divided by 2. That's what that point is there. So that's the coordinates of that halfway point. Let's see what effect that has. In fact, I might comment out the other branch that goes to the right, and I'll just increase that number so we can see more of the tree. There, yeah, you can see. So we've got a line going up and only one coming off that, but here you can see a branch coming off earlier, halfway along. Same here, between here and here you've got one coming off earlier. Let's see what happens if we add that one back in. It's much more dense, isn't it? In some ways it looks more like grasses than a tree. Let's go all the way to that detail. This might take some time to calculate. It's a lot for it to crunch through. Poor computer working hard. Let's see what it comes up with. I can almost feel it straining. Is it going to do it? The reason it's taking a long time is each of those trees has 3 more trees now coming off it, and each of those has 3 more, so it's kind of exponentially getting more detailed. Okay, so I had to stop that and run it again. My browser crashed because it was going too deep. So I've retyped what we were doing. We've done some of the less comments now just to get it typed. It's the same code, and the bit we were working on was the average position along the line, so it's halfway up the line, and I think I set this quite low, which meant that the recursion was getting really deep, and at each point there were 3 trees coming off, so there's kind of an explosive combination going on there. So that's a good lesson to learn, and it's important. I didn't edit that out, the fact that it went wrong in this video, because it's important to understand that recursion can get overly deep and can be too much, really, when you've got a large number of branches happening at each level of detail, whether it's circles or lines or other patterns. So before we had just 2 versions of the shape at each level of detail. Now there were 3, so that kind of adds much more work. So I said 5 was the level of length that we wanted to get down to, and that was almost too much, so it crashed my browser tab. So I've typed it again, and now I'm going to 20. So let's see the effect finally. There, that's interesting, isn't it? So we've got both left and right branches. So if we look at this branch here, that one from there to there, we've got the branch line going there, and then we've got 2 branches, 2 trees splitting off there, but we've got one earlier halfway along, so it's a much more dense, I think it's quite beautiful actually, a really nice dense design, really dense foliage. I like that. I really want to see what it looks like when we go much more detailed. I'm tempted, but I don't know, it might be ages by the time it draws it. Yeah, look at that. Is that nice? What we could do is make it more translucent. So we can say length divided by 20 or 50. See what effect that has. Yeah. Maybe if I divide it by 100. Yeah, no, I think I preferred it quite thick there. I quite like that. Okay, I'm gonna ratchet up the excitement, and maybe I'll see what happens when the length goes down to 15. So it'll take a bit longer to draw. Yeah, that's okay, isn't it? Nice and furry. I almost want to stroke that. That's really nice. Yeah, and I like the fact that it's on one side. It's slightly lopsided because it's only being done on one side. Okay, I really will stop there. I think that's been really exciting. I've surprised myself with what's come out of the code. Didn't expect that. But yeah, have a go yourselves. There's lots of rich opportunities with recursion. Have a play. Don't worry if your code crashes. Don't worry if you've kind of made it branch too much or gone too far detail. Just make sure you save your work and keep a copy of the code so that you don't have to retype it all when it goes like that. Okay, have fun, and we'll see you next time. Cheers. Bye.